What if everything humans have ever built could vanish, not slowly, but completely, leaving behind almost nothing? Not cities, not machines, not even a trace of who we were. Just a thin, silent layer of chemistry buried deep in rock. And what if that has already happened, not once, but long before us? Science doesn't confirm it, but it doesn't rule it out either. Because the deeper we study Earth's past, the more we realize something unsettling. The planet doesn't remember stories, it only remembers consequences. And sometimes, the consequences don't tell us who caused them. Earth does not preserve history the way we imagine. There are no ancient archives carved neatly into stone, no perfect records waiting to be discovered. What survives the passage of millions of years is not structure, not design, not intention. It is residue, a signal, a chemical imbalance locked into layers of rock, stripped of context, stripped of narrative. Scientists don't read the past like a storybook. They interpret fragments, numbers, ratios, trying to reconstruct events from what little remains. In 2018, two researchers, Gavin Schmidt and Adam Frank, posed a question that quietly challenged everything we assume about our place in history. If an advanced civilization had existed on Earth millions of years ago, would we even be able to detect it today? Not prove it, not confirm it, simply detect it. Their conclusion was not dramatic. It was precise. Over geological timescales, civilizations do not leave behind recognizable evidence. They dissolve into chemistry. Concrete erodes. Steel corrodes. Plastics degrade. Even the most durable materials break down under pressure, heat, and time. After millions of years, what remains is not a city, but an anomaly. A subtle shift in isotopes. A trace of carbon where it shouldn't be. A signal that something happened, without revealing what or why. The physical world forgets quickly, much faster than we are comfortable admitting. There is an event in Earth's history that illustrates this perfectly. It is known as the Paleocene-Eocene thermal maximum, a period around 56 million years ago when the planet experienced a sudden and extreme rise in temperature. Massive amounts of carbon entered the atmosphere in what by geological standards was an instant. Oceans acidified, ecosystems collapsed, entire species disappeared. The evidence is undeniable, the cause is not. Scientists have spent decades trying to explain this event. Volcanic activity is one possibility. Methane release from ocean floors is another. The most intriguing detail lies in the carbon itself. Carbon exists in different forms, and these forms carry information about their origin. Biological processes tend to favor lighter carbon isotopes, creating a distinct signature. When scientists analyze the PETM layer, they find a pattern consistent with organic material, carbon that was once part of living systems. This does not point to a civilization, but it does raise a question. What natural process could release such an enormous volume of biologically linked carbon so rapidly? This is where interpretation becomes delicate. Science does not leap to extraordinary conclusions without evidence. And there is no direct evidence of an ancient civilization contributing to this event. But the absence of evidence is not always evidence of absence, especially when the system we are studying is incapable of preserving that type of evidence. The geological record is not designed to capture intelligence. It captures outcomes. Imagine returning to Earth 50 million years from now. Every city we have built would be gone. Skyscrapers reduced to dust, roads absorbed into sediment, technology erased without a trace. Even the most advanced structures would collapse under the relentless pressure of time. What would remain of humanity would not be visible. It would be measurable, a chemical disturbance, a layer of carbon, a subtle deviation in the planet's baseline. That realization changes the question entirely. It shifts the focus from discovery to limitation. The challenge is not finding evidence of past civilizations. The challenge is recognizing that such evidence, if it ever existed, may no longer be distinguishable from natural processes. We are not searching through a clear record. We are interpreting noise, trying to determine whether it hides a signal we cannot fully decode. There are other moments in Earth's history that reflect similar patterns of sudden change. Around 12,800 years ago, during a period known as the Younger Dryas Impact Hypothesis, the planet experienced abrupt cooling, widespread ecological disruption, and the disappearance of large animal populations across multiple continents. Various explanations exist: climate shifts, ocean circulation changes, even possible impact events. Each theory fits part of the data. None explain everything. At the same time, structures like Göbekli Tepe challenge assumptions about early human capability. Built long before the rise of organized civilization, it suggests that knowledge and complexity may not always follow the linear path we expect. It does not rewrite history, but it reminds us that history is not always as simple as we think. Taken together, those examples reveal a deeper truth. Earth's past is not a complete narrative. It is a fragmented record shaped by loss, compression, and transformation. Events leave traces, but traces do not preserve meaning. The further back we look, the more those traces blur into ambiguity. Certainty fades. Questions remain. What if the greatest mystery isn't what existed before us, but whether we could ever recognize it? Earth doesn't hide the past. It transforms it. And somewhere in that transformation, entire stories may have vanished, leaving behind only silent evidence, waiting for someone to finally understand what it means.